Okay, so now we have to find the points at which the graph of x squared plus xy plus y squared equals 6 has a horizontal tangent. We talked about this yesterday. Horizontal tangent means the slope is 0. Vertical tangent means the slope is undefined. Horizontal tangent means the slope is 0. So to find a horizontal, to find anything with a tangent line, we have to find derivative first. So that's the first thing we're going to do, derivative. Okay? So we're going to find derivative for x squared plus xy plus y squared equals 6. Okay? So the derivative is 2x plus, then I have xy, x times y. So I have to use the product rule. So first times the derivative of the second plus the derivative of the first times the second. Okay. And then the derivative of y squared is 2y dy dx. And then derivative of positive 6 is just 0. Okay. I don't have any points to plug in. That's what I'm trying to find. I'm trying to find points. So if I had points to plug in, I could do it now. But since I don't, I'm going to isolate x or dy and dx. So 2x and positive y don't have any dy dx's. So those are going to go to this side. Okay, so mathematically, to do that correct, I have to subtract, since they're both positive. Dy dx plus 2y dy dx equals negative 2x minus y. Okay. Factor out a dy dx, just like I've been doing. Divide by what I don't want to stay. So I get dy dx equals negative 2x minus y, x plus 2y. Okay. Derivative. Dy dx is by itself. Now I'm going to come back to that part where I underlined before. Horizontal tangent lines. That means where the slope is 0. Okay. So I have a derivative with a fraction. So which part of the fraction makes it 0? The top or the bottom? Which part of a fraction will make the whole thing 0? If 0 is where? On top, right? On top. If 0 is on top of a fraction, the whole thing is 0. Bottom is 0, the whole thing is undefined, right? So for this one, we're concerned about the top. So I'm only focused on the top. So I'm going to set the top equal to 0 because I want to know where it's going to be 0. Well, I have an issue again. I have x's and y's. So I need things to plug in. So what did we do last time to figure out what to plug in? How am I going to figure out x's and y's? Because right now, I have that. So what can I do to figure out points? Like I did last time, like I did on problem number 10. Let's see. So let's add y to both sides to solve for y. So we know negative 2x is the same as positive y, right? What are we going to do with that? You're right. We're going to do something with that. What are we going to do with that? There you go. Yep. Plug in what y is equal to. Plug in everywhere there's a y into the original equation. Because if I do that, there will be no x's. Or sorry, there'll be no y's. So everywhere there's a y into the original, I'm going to plug in what it's equal to. Okay, so what is that going to look like? It's going to look like this. It's going to be x squared plus x times y plus y squared equals 6. Everywhere there was a y, I plugged in a negative 2x. Now there's no more y's. I can solve for x now. I can solve for x. So let's see. I have x squared minus 2x squared plus 4x squared, because everything inside the parentheses is to the second power. They're all like terms. So 1x squared minus 2x squared plus 4x squared is positive 3x squared. So I divide both sides by 3 to get x squared by itself. Take the square root of x squared, and I get positive or negative root 2. Positive or negative root 2. Okay. So I'm going to have 2 points. One with a positive root 2 and one with a negative root 2. So how do I come up with the y's now? I need 2 y's. I got 2 x's, I need 2 y's. How do I come up with y's? I have 2 x's, I need 2 y's. How do I come up with the y's? Exactly. Plug it in to the derivative. Where is it true? Where does it make this part true? So I plug in for x, solve for y. Negative 2 parentheses equals y. Negative 2 parentheses equals y. So I'm going to plug in positive root 2 and negative root 2. The first one I get negative 2 root 2. I can't multiply them since one's on the outside and one's on the inside. The other ones I can multiply negative times a negative and makes a positive 2. So when I plugged in positive root 2, I got negative 2 root 2. When I plugged in negative root 2, I got positive 2 root 2. Those are my 2 points. At those 2 points, you're going to get a horizontal tangent line. Okay. Finding horizontal tangent lines and finding vertical tangent lines are very common on free response questions. Those are very common free response questions, especially for this chapter. Okay? So asking you how to do that process is something that you might see on an upcoming test. The tests I haven't graded. I'm going to finish grading them today. They'll be in the grade book today. And then next Friday, a week from today, is the end of the 12-week. Okay? So 12-week grades are coming out. So yeah, just a heads up there to that. So I'll have those tests. You'll have them back on your desk on Monday. When you walk in on Monday, you'll have it. But if you're interested on the grade, I'm going to grade them today after school. So they'll be in four-ish. They should be in the grade book. Okay. Okay. Last one we're going to do. What does it mean when it says d squared y over dx squared? Second derivative, right? We've done that before. We found second derivatives before. Okay. So before you find a second derivative, you got to find the first derivative. So let's do that. 2y dy dx equals 2x plus 2. Solve for dy dx. This one's not too bad. You just divide by 2y. So you get dy over dx equals, I can divide them all by 2. So you get x plus 1. You can divide all of these guys by 2. Let's simplify it. That's the first derivative. Now I got to find derivative of that guy. What am I going to do to find derivative of this guy? Quotient rule. Yeah, quotient rule. Okay. So derivative of, so low, so y times the derivative of the top, which is just 1, minus high, x plus 1, times the derivative of the bottom, which is 1 dy dx over the bottom squared. So what I have is y, and then if I distribute the negative, I get negative x minus 1. Wait, I don't want to do that right now. Wait, let me leave that. Let me leave that alone first. Dy dx over y squared. Okay, and then this is the second derivative, right? Normally, what would I do now? Normally, after this, what would I do? What would be my step to do after this? Get the dy dx by itself, right? But that's not necessarily going to be helpful because I already have a d squared y over here and this guy over here. Yep. No. Okay. I'm not going to solve for dy dx because there's always an equal sign here, and there's a d squared y over here. And plus, am I looking for the first derivative? I'm not looking for the first derivative. So this is where it gets a little different. What is it? I know what this is equal to. Don't I know what this is equal to? So just flip them. Yeah, just use substitution. Do substitution. So I'm going to rewrite it. And instead of dy dx, I'm going to put x plus 1 over y squared. Okay. So this part is technically still inside the brackets. So I have to do that multiplication before I can subtract. Well, this is over 1. So I have y on the outside. I have x minus 1 squared over y squared. Because if I multiply straight across, so multiply fractions straight across, this times this. Okay. So, common denominator. Common denominator for the top is going to be y. So on top, I get y squared over y minus x minus 1 squared over y. So if I have a common denominator, then I can combine them under 1 over 1 guy. Keep change flip. Keep the first one. Keep the top. Multiply by the reciprocal of the second. I get y squared minus x squared over y to the third. I have a y squared on top and I have a y to the third on the bottom. Can I cancel those out? Can I cancel some powers out? I can't. Why not? Yeah, because of this subtraction guy. Because of this subtraction guy, I can't do that. You're done. That's it, as far as I can go. I mean, you could FOIL x minus 1 squared, but it's not necessary. It's not going to help us cancel anything out because it'll just give us more x's. That's about it. So that's the only thing. When you're finding second derivative, when you get a dy dx, plug in what it is. You know it because it's the first derivative, right? It's not a question they ask a lot, but it will be a question that they ask sometimes. So find the first derivative. When you're finding the second derivative and you have a dy dx, plug in what that is, and then go as far as you can. Okay. All right. Okay, so in lieu of the last problem, I'm going to have you guys start working on the practice 14, so that way you can ask questions, if anything comes up. Are you going to be able to finish all 9 problems? No, probably not in, what do we have, 30-something minutes. But at least you can take a look at them. Like 1 through 8, pretty much the same type of problem, right? You're finding the derivative and then plugging in the value, plugging in the values. On the back, it's more 10 and 12 are finding the derivative. So find the derivative, get dy dx by itself. 13 is like what we did here. And then 14 is like what we did with the tangent and normal lines. Okay. All right. Okay. So work on that. If you want me to, the answer key is on Google Classroom.